for application of vector addition. So in a question that we have two vector adding or subtracting, we can use the sine law and cosine law. Let's just look at this question. An airplane is flying at a airspeed of 500 km per hour on the heading of 40 degree. So instead on a heading is just a bearing. From north, you're going 40 degree clockwise. So that is 500 km per hour. It has a 40 degrees. So you start from north and you go clockwise. This is 40. This is a bearing or bearing of or heading 40 degree. 150 km per hour wind is blowing from bearing of 120. So bearing of 120, you start from the north and you go clockwise 120. So from here to here is 120. Because it said from means it's the beginning of that is here and direction of that is like that. Just to note it, this is from here to here is 120 degree. And it is 150 kilometer per hour. 150 kilometer per hour. So knowing that the airplane is flying with that, and this is wind, so wind pushing the airplane. That's why an observer on the Earth will see the resultant of this adding these two vectors, because this is pushing the airplane. So the resulting of the vector going to be from the beginning to the end. I have to add this vector. See someone from ground, see the airplane with this velocity. Now, we can use cosine law. First, we need to find the angle between these two vectors. If from here to here is 120, and this is 40, of course, the angle between these two vectors are going to be 120 minus 40, which is 80 degree. So using the cosine law, remind you, if you have A and you have B, and you have angle between them is theta, you can find the third one, which is C. So C power 2 is A power 2 plus B power 2 minus 2 AB cosine of theta. Sorry, this is the cosine law. We use that. We have A, which is 500. We have B, 150. And cosine theta, theta is 80 degree. So as you see, we do that there. Then to find C, I have to take a square root of that, right? We do that and we get the total vector. Then another things we need to do, we need to find the angle. We can use the sine law to do the angle. So knowing this is 80 and we have 3 sides, right? So this side we get 496.45. Use sine law. Sine of 80. Oops, sorry. Sine of 80 divided by the opposite side is 496.45 equal to I'm gonna find the sine of this angle theta. Sine theta divided by, so opposite to that is 500. So I'm reading for sine theta, gonna be 500 go to there, so that's 500. sine 80 divided by 496.45. Find theta, just take a sine inverse of this number here and you get 82.68. So this is going to be 82.68. 82.68. Since we wanted to find the angle it's making with horizontal, right? We can do that. Knowing this angle is from here to here is 120. So this angle will be 180 minus 100, so it's going to be 60. So this is the right angle triangle. So it's going to be 30. And this angle here, easily we can find it by saying 180 minus 30 minus, this is roughly 83, right? Minus 83. So this angle will give you 67. So 67. So we got the angle. So here the magnitude, we got 496.45 and the angle 67 to the horizontal, or you can say east 67 north will be the resultant. Okay, there is another example here. I'm going to erase that. Determine the resultant of the vector sum of 1,200 Newton at 120. So, and then at 300 degrees. So is a bearing of 120 means you just start from north and clockwise, you go 120. So that's it. Just from here to here is 120. And then the next vector, because it said the sum of that, the vector sum 1,020 at 120, and then 1,100 Newton at 300. So the direction of that this is, now the next vector is 300. So you start from that and you go 300. So it would be there. So from here to here is 300. Okay, knowing that this is 300, of course, this will be 60 degree, right? Also, this will give you 30 degree. If this is 100, so 90 plus 30 degrees. So from here to here is going to be 30. So it's going to be along each other. Adding these two vectors that is really parallel, you just simply minus their value because they are opposite and along each other, right? But this one is 1,200, and this one is 1,100. So simply this one is, that would be the resultant. And since this is bigger, bigger, so the direction gonna be, just do that, it's gonna be east 30 south, east 30 south, since this one is bigger. So it's gonna be 1,200 minus 1,100, so that the resultant gonna be in this direction. Here's another example, 15 Okay, so here is another example. 50 meters per second square at 80 above the horizontal. So it means we have a vector 80 degree above horizontal here. Is 15 meters per second square. Gravitational acceleration is 9.8. So gravitational acceleration is downward. If you look at that, because I want to put it back to back, these two vectors. So my second vector is down, straightly down there. And now it's a little bit less than 15. This is 9.8. Let's see, this is a vector. And here is 9.8. So I want to find the addition of these two vectors. If I put it back to back, so this would be the addition of this vector. Okay. So knowing that so this is a Z pattern. So if this is 80, according to Z pattern, this is 80 as well. And I know this is 90 degree. Therefore, total degree here is 180. So it means this should be 90 degrees. So it's going to be 10 degree here. Now, knowing that this is 10 degree, we have two vector, two side, just 15, 9.8, an angle between them. We can use the cosine law. It's 15 power to plus 9.8 power to minus twice of the 15 multiplied by 9.8 cosine of the angle between them, which is 10, cosine of the 10. So take a square root r, the resultant is going to be 5.61 meters per second squared. Then we can use the sine law. So if I put this to be this angle here, to be alpha, so it's going to be sine of the alpha over the opposite side, which is 9.8, is equal to sine of 10 over the resultant, which is 5.6. As you see, we'll see that there. So just rearranging for sine alpha, take a sine inverse of the thing. So you get the alpha to be 17.66. So here is 17.66. Knowing this is total angle is 80, so, and here's alpha. We can find this angle by saying this is 80. This angle here, I call it theta, will be 80 degree minus 17.66. So that would be the angle theta. Or I can find this above angle. If this is 70, the total is 80. So you have that to be 10, right? And 10 plus 1766, angle from here to here is 27.6. This is approximately, I call it 27.7. So this is north, 27.7 to east, as you see here. You put the magnitude and here is the direction. Okay, here is another question. A box weighing 450 Newton is hanging from two things attached to an overhead beam at an angle of 70 and 70. So this is the object. So we have two ropes. This is the ceiling. we have two ropes attached to each other like that. Then you have an object hanging here. This is the object hanging here. Of course, there is going to be a, that's okay, angle between that. Here is 78. And angle this one make with the ceiling is 70. We know the tension is out of the object toward the rope. So this is T1, let's say, and here is T2. T2, we have a gravitational force. So this has a weight. We have F of G. F of G is given is 450 Newton. Okay, so knowing this is a stationary means all of these vectors need to add up 0. Or you can say that addition of these two vectors, T1 and T2, should be along with 450, but in opposite direction in order to cancel it and make this one to be stationary. So I'm just drawing that. So if this is T1, this is T1, I put this one, I just move it parallel here. So this is T2, right? Here is, I move it here in a parallel way. So this is T2. The addition of these two vectors need to really be straight up. Why? Because this vector need to cancel the weight here. So this is an equilibrium, means all forces cancel each other, means this need to cancel the resultant 400. So this is 450. Knowing this is 78, let's see, Z pattern, this is 78. Means here we have 78. Therefore, this is 90. This will give you 90 minus 78, so you have 12 degree here. Same thing here, we have see, this is with the x-axis, this is 70. See, here is 70 degree here. CZ pattern is going to be 70 as well. Here is 90 degrees, 70 minus 90 minus 70 is 20. So you have 20 here. So I have two angles. So I can find this, the third one, right? Again, this is 70. This is going to be Z pattern 79 here. I have total angle here, which is the 148. If you add that, total angle here will be 148 angle. The triangle is known. I have one side. I can use the sine law to find T1 and T2. So 450 divided by sine of 148 equal to T1 divided by sine 20. You can rearrange for T1. Same thing. 450 divided by sine of 148 is T2 divided by sine of 12. See here, arrange for T2 and we get that. Also, we know the direction of that, of course, is north 12 to the west, and this one is east 70 north. You can use those. Okay, for the worksheet, you can do question number 1, G and H. Question number 2, you can do question number 5, and question number 11.